In this question, we're asked from a deck of 52 cards. It's a standard deck of playing cards where you've got the 4 suits and per suit 13 cards. A king is drawn and kept, meaning it is without replacement. The deck is then reshuffled. What is the probability the next card drawn will be a 10, given that the first card was a king? The easiest way to answer this is to think of the restricted sample space. After you've taken the one card, you've got 51 left, and then you draw at random another one. And since the first one was a king, you still have 4 of the 10s that you could draw. So this is going to be 4 out of 51. Compare that against using the formula. So what would be the probability that we could, let's see here. Event A is the first was a king. And then event B would be that the second card is a 10. So see the formula. The probability of A, we would have the size of that event over the size of the sample space. Similarly, in the numerator, size of the event over the size of the sample space. Remember, we're drawing at random so that we have equally likely outcomes out of a sample size of 52, a sample space of size 52. Okay, so we have 4 kings, and then we have, let's see here. Think for a minute. Okay. A little bit of an error there. The sample space would be all the ways that you could pick 2 cards, first, then second, no replacements. So I should have 52P2 here. Down here, pick the first card as a king, and then pick any other card. Versus up here, pick both the king and then pick the 10. Copy dot flip, as some call this. Turns out we don't really need to know what 52P2 is, because that's going to cancel out. And the 4s here will cancel out, leaving us the same result of 4 out of 51. So this was another example where thinking about the restricted sample space made this easier. However, that's not going to be the case for several examples.